Alright, so today we're going to start 9.3, and it's titled Geometric Sequences. So remember, yesterday we finished up arithmetic sequences. What was how did we know a sequence was arithmetic? So we had a common difference that was the same. What was how did we find that common difference? What did we do? So you were finding out if you added or subtracted the same number from each number. So okay, so I'll give you an example.
Just one multiplying dividing.
So if we had 1, 2, 3, 4, 5, what's our common difference? 1. So how did we find that? We're adding 1 each time. Okay, so that was what we did yesterday and on Wednesday. So today I want you to look at this sequence, and I want you to tell me the next term in this sequence, and I want you to tell me how you found this term. Okay, so Lauren, what did you get for your next term?
48.
Okay, so we get 48. Does everybody agree that the next term is 48?
Yes.
How did we find that? So we're multiplying each term by 2. So, and how did we find this next term? The pattern is multiplying by 2. How did we find that 2?
Just all the pattern.
So you just saw the pattern. Is there an actual way that we could find that 2? Without a formula. This is like one of the most important things about this section, is being able to find that pattern and how you found it. So does anybody have any idea how we could tell that we're multiplying by 2?
Divide 74 by 2, divide 12 by 2.
So what'd you say, Michaela?
If you divide 24 by 2, you get 12. If you divide 12 by 2, you get 6. And if you divide 6 by 2, you get 3.
Okay, so you divided each term by 2, and that got you the previous term. Okay, so if we're dividing by 2, what?
That only works in this case, though.
That only works in this case. So we're kind of looking for a more general thing. But you're on the right track. It has to do with dividing. We're dividing something by something. So I'll kind of give you a hint. For geometric sequences, which this is, instead of having a common difference like we did with the arithmetic sequences, we have a common ratio. So a ratio is like a fraction. Well, 2 is not a fraction, but how could we get a common fraction? We're doing something similar to what we did with the arithmetic sequences. It has to do with your terms that you have. Any ideas? I know this one's kind of confusing to think about. All right, so I'll give you a hint. Well, I'll actually show you. So to get that 2, we're going to take, like Michaela said, we're going to take our next term, wherever that happens to be. So in this case, we'll take the 6, and we're going to divide by the previous term. So we're going to divide by 3. And what does that give us? 2. What if we took 12 and divided by the previous term? So 6. 2. So does that give us our 2? So that's what we're looking at with these geometric sequences. You have to find that common ratio. So you're going to be dividing 2 consecutive terms. The second term by the previous one. Is everybody kind of clear with that? Because they're not all going to be whole numbers. We won't always be multiplying by 2.
What if there's not a previous number?
There should always, you should have at least 2 numbers.
Yeah, 'cause
Otherwise, then you can't tell if it's a geometric sequence or not. Okay? So you always should have 2 numbers. Alright. So our geometric sequence is going to look something like this. We'll have our A value, which is our first value in the sequence. And then to find our second value, we just said we're multiplying by that ratio. Our third value, we're going to multiply by that ratio again. So how did we get that squared? Because these have exponents. Where are those coming from? So we're multiplying by r again. So if we're multiplying r by r, what is that? R times r. So that's r squared. So each time we multiply by an r, we're increasing our exponent. So these geometric sequences are going to have exponents. So in example 1, we have A, B, and C. And I want you to determine whether each sequence is geometric. And if it is geometric, give me the r value. So how do we tell if a sequence is geometric?
Take the next number and divide it by the previous number.
But what do we need to tell that it's geometric?
A number? Numbers?
So with an arithmetic mean, we needed the common difference. So what do we need for a geometric?
Common ratio.
So we need the common ratio.
Oh.
So do A, B, and see if you get a common ratio.
No.
I want everybody to try A, B, and C.
So this one you can't add or subtract, right?
No. We're just telling if it's a geometric sequence.
What type of sequence would it be if it was adding and subtracting?
The other one.
Yeah.
Well, the first one is no.
Why,
The
it
other
goes up by 3.
I'm not good with math.
You get the other. We're not adding
Yeah, that
the
one.
multiplying by. Wait, what?
I learned one thing, and then we do the next thing. Yeah, because if you add 2 times 2 is 4.
Yep.
And the last one is 6. Yeah, why are you doing work? You just do no yes, yes.
Miss Audio.
I'm just trying to
Yes,
show you the
yes.
easy approach. Is it no, yes, yes?
Yes.
Sure.
I know it. Don't ask me.
And it just looks like no,
I'm
yes,
not-
yes.
This just looks.
Times by 2.
It's actually-
I'm gonna just sling it in, come here.
I'm sorry.
Just laying it there.
That was by 2.
Okay, but how do you get it?
Did I just come here?
Wait,
Sometimes she was
you're not having it nice and neat like that. You
This
gotta know
one's
how you
mine.
find- Okay, why not?
Right, for regular
It's like, what's your first name?
Yes, that's mine.
Yeah, I give you.
Yes.
They're not gonna be all nice like that.
I feel like it's like Ann.
I'm right though, right?
What is it?
I'm right though, right? Okay.
But you have to be able to.
Just laying it there.
I did.
Alright, you guys gotta stop with that.
Ding, ding, ding.
What's your first name? I think it's Karen.
Alright, so it's sounding like we all found them.
I don't know, it just came to my head.
Alright,
Yeah.
so first thing. A, is it geometric?
No.
No.
Why not?
Because it doesn't times or multiply.
Divide.
3 times 3 is not 6.
It's all on the condition in this folder.
So what did we say we needed to tell if it was geometric or not?
Common ratio.
Common ratio. So how do we find our common ratio?
6 divided by 3.
So we do, Kaylin, we do 6 divided by 3. What do we get? What do you get? 2.
Did you?
Okay, so that tells us between those two, but we want to check more because that only tells us between those first two. So what are we going to do next?
Then you do 9 divided by 6, right?
Then we do 9 divided by 6. What do we get for that one? Not 2.
3.
So you get 3 halves. Ladies, are you paying attention?
Yes,
Yes.
Ms. Lang. Today.
Ladies. So you get 3 halves. So you can stop right there or you can keep going. Are those two ratios the same?
No.
No. So that's why it's not geometric. Is everybody clear with that? This, part A, could it be a different kind of sequence?
What do you mean?
Yes.
Oh, yeah,
No,
it's
that
the
has to be-
arithmetic.
Yeah, it could be the first one.
So we would have a common difference of adding 3, so it could be an arithmetic sequence.
Yes.
But we're just checking if it's geometric. So in this case, it's not geometric.
So geometric is only multiplication and division, and then arithmetic, or the one we learned the other day is addition and subtraction.
Essentially. Again, for geometric, we want to think about ratio rather than multiplying and dividing. You always want to be thinking about the ratio. Because these aren't all, like these are kind of easy to tell. They're not all going to be this easy. You're going to have harder ones that you're actually going to have to figure out if the ratio works or not. All right, so part B, geometric or not?
Yes.
Okay, and how did we find that?
The same way we have
What's our common ratio?
Just stop laughing.
And how did you find that? It always goes back to how you found it. How do you get it? What'd you say, Brandon?
4 divided by 2 is 2.
So we take 4 divided by 2 is 2. Then what? 8 divided by 4 is 2. And 16 divided by 8 is also 2. So all of our ratios are the same. So that tells us that it's geometric. And then part C. Geometric or not?
Yes.
Yeah.
So yes. And what did we find for a common ratio?
2.
What did we find for a common ratio?
Isn't it half?
Why would it be a half?
Divided by 2.
Because
what?
it's half.
So what
I
did
don't know how to
how?
explain it.
So what did we do? We took
24 over
24 over 48,
which is half.
which equals 1/2,
And then the 12 over 24 is half.
and that gives us a half, and 6 over 12 gives us a half.
Yeah.
So this time our common ratio is 1/2. So we are dividing by 2, but again, you want the ratio. And we'll see why in just a second. Well, actually, we already saw that. Because we said that our pattern for a geometric sequence was right here, right? We have our first term, and then we're multiplying by that ratio, right? So we're never dividing. We're always multiplying. So here where you guys say that we're dividing by 2, yeah, we are. But we're multiplying by a half. You have to realize that those are the same thing. Is everybody clear with this? Those ratios are important. Alright, so just like with arithmetic sequences, we have an explicit formula and a recursive formula. And you're going to use the different formulas for different tasks. So here we're asking for the general explicit form for a geometric sequence. Now it's a little hard to kind of think about on your own. But what it is, it's an equals a1 multiplied by r to the n minus 1. So we need to define what each of those means. Remember that these are notations for different things. So what was our a1 value? What was that?
What you were trying to find.
a1.
Oh, what our first term was.
a1 was our first term in our sequence. Because in order to use this formula, we have to know what all these mean. So a1 is our first term in the sequence. What's our r value? Is the ratio. And again, how do we find the ratio? How did we find the ratio?
Dividing.
We're doing what?
Multiplying.
What? Kaylin, what'd you say?
I don't know.
Come on, it's okay.
I don't know.
You don't know. You said something. What'd you say?
Come on, Katie.
I don't know.
Jack, what'd you say?
I said something else.
So when we had our sets, how were we finding those common ratios?
Dividing them.
So we're dividing the terms. So we're putting one of our numbers over another one of our numbers. The consecutive ones, remember, is how we find our common ratio. You have to know how to find that common ratio. What's our an value? What is an? It's what, Jack?
That's what we're trying to find. The missing term.
So it's the term that we're trying to find. So for example, if I wanted the 100th term, what's an? It's a100. That's just telling you the term that we're looking for. So what's our n value then?
Is it what you're dividing by?
The n value? What's the n value tell us?
What the term
So you're on the right track, Michaela. What the term is, what do you mean, what the term is? So like back to my example, if I'm looking for the 100th term, what's my n value?
is. Would that be like 100?
Yeah, so my n value would be 100. So what is that telling us?
That's the one that you're trying to find.
So we're trying to find the 100th value. So it's the number of the term we're looking for. So I know an and n kind of look the same. And we had a question about this in first hour. I was asked, what's the difference? Well, what is the difference? Can anybody tell me what the difference between an and n is? Michaela.
The AN is like, it's gonna be like, whatever the number we find like equals to, that's what that term is gonna be. But then the N is the one before it, so that's how we're finding what the value, that makes sense.
Okay, so you're exactly right on what an is. That it's the actual number that we're looking for. So it's going to be, like our answer is an. So if we're looking for the 100th term, it's going to be the 100th term, whatever that term happens to be. N, however, I need somebody else to clarify what n is. N is? So here we're saying n is the number of the term being found. So it's not the term that we're actually finding, it's just the number of the term we're looking for. So again, if we're looking for the 100th term, it's just 100 terms in, is what that's telling us. It's basically a placement. It's telling us which number we should be looking at. Is that clear? These can get confusing, so I want to make sure that you're clear. If you have questions, ask now. It's better to ask now than later. All right. So, in example 2, we're actually going to put that explicit formula to use. For part A, we want to find the 10th term of the geometric sequence that starts 4, 12, 36. So you need to find the 10th term. This should be very similar to what we did with the arithmetic sequences. So I want you to do A and B right now. And then I'm going to have somebody explain what we did. So do A and B. Christian, I need you off your phone. Now.
So, this is like A1 side.
I got a question. Do I have to use the formula or?
If you're not sure, work with your neighbor.
For number 1.
Maybe they know how to do it. Maybe they can explain it to you.
I mean, you can go times it by 3 is one time. You know, write it out. That's one way to do it. But if you use the formula, it's going to be a lot quicker. So it's A. What's your first?
Is it n minus 1?
Four.
Okay, so start by writing 4. Now, what's the ratio that it's going up by?
But minus 1 is not.
It's going up by 3, so that's going to be your R value. Okay, so it's 4 times 3.
Is that A and or what is that?
So what did we
12 times,
What's A and?
12 times 3 is 36.
Oh,
3 times
Now-
12.
Now, that 3 has to be raised to the n minus 1. So what's our term value? that's going
wait,
down?
so A to the 1, what is that? That's the 3?
I don't get
A
it.
to, well, A to the 1 is your first term.
Look at mine.
Oh, I thought so.
What's your first term?
Oh, mine is.
It's 4.
R is your ratio.
That's like 7,
Okay.
So we're looking for the
78,000.
n minus 1. So I put 10
So what
here.
was our N? What's our N value?
This is what,
I never noticed that.
A1, that's your first term.
Managers are curious.
Right, yeah.
What'd you do?
I just wrote
It
those.
can't be to the 9th power because 3 to the 9th power is like 1,900.
So,
Yeah.
oh
And
yeah,
then
so
if
it'd
you
be
times it
8
by
to
4,
the
that's not
That
right.
wouldn't
I was
work.
saying 700. No, that's not right. Yeah, that's not right. Maybe you should be.
Yeah, 1 is B 10, right? Because that's the term.
Yeah, so if you A to equal
Okay, so
Hello.
A1,
Oh, I didn't know I had to put the A there.
second row towards
there's no way.
and
Why
then
not?
That's too big.
Well, what are we doing?
Okay, so what's your first term?
Each term you're multiplying by 3.
What's your ratio?
Yeah.
That's huge.
3.
Okay, so we're gonna talk about that.
And then what,
So it's
what's
supposed
my
to be right.
N?
I would never put that number down.
Is it supposed to be this long?
And is this
Did you get this?
That's like 12
Well, one
numbers.
second, times by
It's like
4.
12 numbers.
I
Oh,
got
yeah.
78,732.
Yes.
I got 7,872.
times.
I got these.
So we're doing 4 times
It's not
3.
99, where'd you get
Oh, it's 10. That explains why.
So we
Okay.
have to do that first, right?
So you have to
So I had to go through some slides here, so that's how I got home. And then where do you?
So you're just gonna, the 20 minus 1 will give you 2 to the 19.
Might as well move on to the next one.
Chelsea, did you get number B?
Number of.
Okay.
No, I didn't.
Do you know how to do it?
Yeah.
Yeah.
Kaylin, can you get that?
Okay, you said finish your question. How do you do that?
Michaela, did you?
Keelan, can I have my You right, I swear.
She stole my calculator. Oh my god, you need to.
Mr. Duke.
Huh?
Hello. Do I have what?
Yes, okay, so
You said two big numbers.
Yeah, but you need the 8. Is
10
that the number you're
times.
looking at, the 20 and
I
10?
can't find
Yeah,
that. It's you.
Okay. I'm gonna show you the easy
Sorry.
one.
Alright, you show me
Okay.
the easy one.
Alright.
Because I can't hear.
Alright, so is everybody finishing up or do you need a little more time for A and B? A little bit more? Alright.
Oh, we're doing B2, I forgot.
Alright, what's your ratio?
I think this is easier than what we learned yesterday.
Maybe that is right. Why don't you just go,
No.
there's an easier way of doing this.
What's n minus
What do you
1?
mean? You're doing it
Well,
the
what's
easier
that?
way.
Okay, the 10.
Class Wizard.
Minus one.
Wait, Michaela,
Yeah,
you
but
get
that's
this?
the raise to it, right?
Michaela?
So it's 3 to the 10 minus 1.
Yeah, I think
So
There's
this
an
is
easier way of
4.
doing this. This is an easy way of doing that.
I just did.
R means what again?
10 minus 1 is 9.
Yeah.
And that's
Yeah.
what it's.
But in the common ratio.
Put it in the calculator and get these. Okay. Yeah, it's much more.
Because for that one, you
Yeah.
can you do that for that one? So you can only do it for that
So
one.
wait, is it that?
Yes, you do get that. Because that's just using exponentials.
Michaela, did you get this?
Yeah.
Okay,
I did.
this is the easy way to do it. Okay. All I do, write down the second part of the formula. A1 sine r to the n minus 1. So you need to know what A1 is.
Yes, I get it. That is.
A1 is your first term. What's your first term there?
Did I do this right?
So right underneath A1.
I tried to tune it out, as you can see by my
Now
legs.
times that by r. What's your r value?
3.
It's 3, right? So right there. Now, what term are you looking
4
for?
times 3 is 10.
So 10 minus 1. Up top.
Alright, so are we finished up now? We can go over them? Alright,
Okay, now I get it. That's so easy.
Thank you.
so part A. We want to find the 10th term of the geometric sequence. So again, what is our explicit formula that we're using? Because that's the only formula we've been given so far. Alright, I need everybody to come back now. We've discussed. Okay, so now these can get really boring. We're just plugging numbers in, I know.
Oh, yeah.
So that's why it's important to know where the numbers are coming from. So again, we're looking for our 10th term. So you tell me, what do we know? What can I put into this formula? Where does it come from? So we're finding the 10th term, so what does that mean? So we're finding A sub 10. That's our notation for our 10th term. Okay, what else do we know? We know our first term. That's our A1 value, remember.
4.
So it's 4.
The ratio, which is the common.
So what do we find for our common ratio in this case?
3.
Jenna and Amanda.
We're talking about letter B.
So we found our common ratio to be what? 3. 12 divided by 4 gives us 3. Okay, what else?
N, which is
N is 10.
the term, so it's 10.
N was our 10 because we're finding the 10th term, right?
And then minus 1.
And then minus 1.
Then you do the exponents first, so it would be 3 to the 9th power.
So you get 3 to the 9th times 4. And what did we get?
78732.
Nice.
Okay, and I had a question over there. Can that be right? It's so big. How is it possibly right?
It's right.
Well, what are we doing?
Multiplying by 3.
So how is that different from what we were doing yesterday?
We're adding.
You're adding it.
We were just adding and subtracting, right?
So the numbers weren't as big.
So these numbers are going to get big, and they're going to get big quick.
You guys remember well, we did it earlier this year when we were looking at exponential functions, how fast it grows. That's kind of the same idea with geometric series. The numbers are going to go really fast because it's an exponential function and it goes up like that curve. That helps.
Good point.
Okay, I have a question. So that formula, you're taking, okay, the first term times the common ratio to the power of n minus 1. Why are you subtracting 1? Why don't you just multiply it by r to the n?
That's a
Good
good
question.
question.
That is a good question.
So think about it.
Okay, so that's one answer, and that's a good answer. But
I'm just following the formula. Like,
okay, so why do you think the formula says that?
Because you have to find the one before it to find the one like in the sequence. We were trying to find the 10th term, but
They want the 9th term to get the rest of it.
And maybe.
So, okay, so his question, look at the formula. What are you doing? What are you doing here? So he's asking why this is n minus 1.
Well, I know we're looking.
Because we're not trying to find like the 11th term, trying to find the 10th, so why would we times it by like 10?
Well, wouldn't it be 11 if we were looking for the 11th term though? So.
No.
Oh man, I'm confused.
It would be 11 minus
now I'm
1.
Curveball.
No, so okay, so Andrew, you're kind of on the right track. What is this term?
The first term.
Okay? So we're already using our first term, right?
Oh, so the one's already used, that's why we have to subtract.
So we're already using one term.
Okay, got it.
So why would we multiply by that again? You know, why would we multiply that again?
Yeah.
I get it now.
That makes sense. Because you need the term before it to like
Yeah.
figure it out.
I'm still confused.
So that's good. So a way that I like to think about it is, okay, so you,
Ladies,
okay, hold on one second. Just want to say one thing. Okay, so you're starting with the first term, and then the question is, how many 3's are you multiplying it by? You're just going to
10.
multiply, you're just going to, well, if it's the 10th term, you're starting with the first one, and then you're going to multiply it by, so you've got the first thing, then you multiply it by 3, then by 3 again, then by 3 again,
Oh,
then
so
by
you only
3
need
again.
9 because
So-
if you did 10, it
You
would
only
be
got
11. I got
Yes.
you. I
Alright.
got you.
Explain it to everybody else.
Okay, basically we already have the first term, so if we were looking for 10 more, that would be 11 because 1 plus 10 is 11. So we subtract the one that we're looking for. So we just
Yeah, that makes sense.
Yeah,
I got it.
I got it.
Alright,
We good.
alright,
Why did you take all
good
the?
question. I like that question. Keep that question. Alright, so B. This time we're looking for the 20th term. So again, we're just using the formula. I know, it gets boring. You like it? You like the boring formula?
It's better than graphs. I hate graphs.
Okay, so what do we know this time? What are we doing? So what are we taking? A sub 20,
And the first term, which is 2.
our first term is 2.
Common ratio, which is also 2.
Our common ratio is also 2 this time.
And then you
Again, how did we find that? I'm gonna emphasize it every time because it's very important. You're taking your second, in this case, we're taking the second term dividing by the first term to get our ratio, which is 2 in this case. But you could take any 2 consecutive terms and you should get 2. So then what's our n minus 1?
20 minus
20 minus 1. So we have 2 times 2 to the 19th. Now Michaela made an interesting observation with this one. She's like, I punched it in and I get this number, but then I took 2 to the 20th and I get the same number. So why is that?
Wait, she
She plugged that in,
plugged 2
like it is
times,
right there.
2 to the 19,
uh-huh,
and then she got.
and she got our answer, so what's our answer?
1,048,576.
Well, big number.
Okay, so we get that number.
Okay.
So she said that she got that by plugging that in. Well, then she plugged in 2 to the 20th, and she got the same answer. Can somebody tell me why?
Because it's multiplied by 2, so that would be like adding another exponent.
So that goes back to our exponent rules where we just add our exponents.
Yeah, it's kind of like what he said.
So in this case, just because they're the same, our two bases are the same, we can combine our exponents. It's not going to work like that for all of them. It just so happens that it worked for this one. So. All right. So then we're going to do C, and we'll be done for today. I know, right? All right. So part C. So part C goes back to what we were talking about with arithmetic sequences as well. Remember, if we were asked for the second and third terms in an arithmetic sequence, what did we have to find in order to find that second and third term? Thinking back to our arithmetic sequences. What do we need to know?
Oh wait, I got this, hold on. Hold that thought.
Where are you guys?
On the floor. Everybody learns the best.
Exactly.
So what did we need, Dennis?
I got a question.
Yes.
You have to do a different formula for this because you're looking for 2 terms instead of 1 term.
So we're going to look at that. So that's what we're talking about. If you're given the first term and you want to find the second term, how do you get from the first term to the second term? Yes, Dennis.
Okay, you take 2 plus negative 54 and then divide it by 2 to find the mean.
So okay, so that was fine when we were finding the mean. This time we're looking for 2 terms in the middle. We're not looking for a middle term specifically.
What did you,
Yes.
did you do like how we put it on the x and the y? We just put 1 and then 2 and then that's the 4?
No, so that's the mean. That's if you're just looking for that middle number with your arithmetic sequence.
Oh, so this is something totally different. Like that's not what the same thing.
Go ahead. No, if you
Start by writing down the geometric formula. So start by writing that down. What do we already know? We already have the fourth term, right? So could we substitute something in for a sub n instead of having that sit there? What's the fourth term?
-4.
So where would we put negative 54 in there?
The minus n minus
Okay, so what I'm trying to get at is to get from your first term to your second term. How do you go from one term to the next in a geometric sequence?
You're probably
Multiply.
You're multiplying. So what do we need to multiply by?
Any number?
What is it in a geometric sequence? What is that?
A ratio.
It's our ratio. So we have to find our common ratio.
How do we do that?
Well, that's what we're going to see. So we're looking for R. You need to find R. Otherwise, you can't get to your second term and then get to your third term. Huh?
So R is X.
Just put x for r?
Or keep.
Well, you just leave it as an R.
Oh.
You'll just solve for R. So what Mr. Duke was getting at is we're given the first term and then we're given the fourth term. So how can we use that in our formula to help us find R?
Can't you just put like -54 as an and then put
So, okay, you want to put negative 54 as an, all right.
and then put 4 for n?
So your our n value would be 4 then, okay.
Where'd you get 4 at?
I got a question too.
Oh.
Okay, hang on, wait. So what?
Why did we put negative 54 if that's not what we're looking for?
We're looking for R.
We don't know what R is.
We don't know what R is.
So we leave it as R.
So yes, we're gonna leave it, we're solving for R.
And then you put 2 for A1, right?
So, what do we put for the end?
Okay, so Michaela just said, we're gonna put negative 54 as our AN value, okay?
So we leave it at.
Okay.
So what term is negative 54?
4.
Our fourth term. So what does that mean our N value is?
4.
Is 4. N equals 4.
So then would you put the 2 where the A1 is?
So our
First term
A1,
is 2.
Yeah.
so our
then
first term is 2.
times R to the third. Right?
So it would, yeah, it would be
Yes.
4 minus 1, which ends up equaling 3, yes.
Yeah, you said
And then
So if we simplified like Kaylin said, you get negative 54 equals 2 times R to the third. So is everyone clear?
You divide it by 2 and then take the square root of both sides.
Are you gonna take the square root?
Cube root, that's what I meant. Yeah.
Exactly, so we're solving for, so this is just an algebra problem. You're just solving for R.
It's easy. I don't know.
So we'll divide by 2, like you guys said. So when we divide negative 54 by 2, what do we get?
Negative 27.
Negative 27. And that equals now R cubed. So then what did you say we're gonna do?
Cube root of 27.
Rooted
So we're cube rooting.
That makes sense.
And when you cube root negative 27, what do you get?
negative 3.
You get negative 3. Negative 3 cubed is negative 27. So now we have our R value. Can you find the second and third term now?
Yeah.
What do you mean?
You just plug in.
How do you get from the first term to the second term?
Multiply
Where
negative
do we
3.
put negative?
You just multiply by negative 3. Why is that going to take forever?
Wait, so would the answer be R or would the answer be the third?
It wants the second and third terms. That's your answer. But you have to find the R to get that second and third term. So it's negative 6 and 18.
Negative 18. Then positive.
No, it's a positive 18 because negative times negative equals positive.
Oh my.
No, it's
This is
negative.
all in video, little good video.
So to get your, okay, so to be clear, to get your second term, multiply 2 by negative 3, you get negative 6. To get your third term, multiply negative 6 by negative 3. A negative times a negative gives you the positive. And it's 18.
So if it kept on going, it would be like negative and a positive.
Mm-hmm. All right, so that's where we're going to end today.